ran into a problem today on the mixed review units 1 through 7 that I realized I had not created a teaching video on this. It was in one of their AP Live videos, but I thought I had created a video and a Mimeo file even on this, but I had not. So I wanted to take a minute to go over it with you because it's not real hard and it's very important. And that's this idea of the derivatives of inverse functions. This should say inverse functions, not inverse trig functions, I'm sorry. So just in general, the derivatives of inverse functions. So first, let's review a couple things. Okay, first off, when we talk about inverse functions, there's something that we know. First, if I plug an inverse function, okay, if I plug two inverse functions into each other, they always simplify to x. So if h and g are inverses, then if I plug them into each other, either h of g or g of h, they will always simplify to x. That is the first important point. The second important point is that if two functions are inverses of each other, let's look at a classic example of the square root of x and x squared. Get a different color here. These two are inverse functions of each other, and if you remember, they're always reflected across the line y equals x. But what's more important is the fact that, and especially in this AP Calculus work, here's what's real important. If I come over here to x equals 4, okay, if I put a 4 into this function, the square root of 4 is 2. That means that right here, the coordinates of this point are 4, 2. And here's what's very important in these AP Calculus inverse problems. If this point 4, 2 is on this function, then on the inverse function, there is going to be the point, it is guaranteed if they are inverse functions, there is going to be the point 2, 4. And think about it. If I put a 2 in for x here, isn't 2 squared equal to 4? All right. So this is very important in understanding these inverse problems on the AP exam. If you can understand that and understand the next thing I'm going to show you, they are not very hard. Okay. So what I want to do is I want to come back to this, all right, and I want to take the derivative of it, and I'm going to do that on the next screen. So if I have that statement, h and g are inverses, so h of g of x equals x, then if I find the derivative, we do the chain rule, right? H prime of g of x times g prime of x. And then I need to do the derivative of the right side, which is 1. All right? So let's divide both sides now by this h prime of g of x. And what I get is this nice little statement here, g prime of x equals 1 over h prime of g of x. And that statement can solve so many problems on these derivatives of inverses. And so this is 0.3 right here. But what I want you to remember is that it can go both directions. So not only could I have g prime of x equals 1 over h prime of g of x, I could also have that h prime of x equals 1 over, all we're doing here is we're just flipping these around, okay? 1 over g prime of h of x. And the reason that's true, okay, so both of these could be true. And the reason that is because of this statement, because h of g of x will always simplify to x, and g of h of x will always simplify to x if they are inverse functions. Now, what I wanted to do was then tie this in to this problem that we dealt with in the mixed review, all right, and especially this part B right here. Let m be the function defined by m of g of x equals x. In other words, m and g are inverses. Find m prime of 4. The moment that you see this, m of g of x equals x, or the moment that you see that they're talking about two functions being inverses, then you're coming back to this statement that I made right here, okay? And so I'm going to be thinking, which one do I want? Well, I'm looking for m prime of 4, okay? So that means I need to think, I want the expression that's m prime of x. So that's going to be 1 over, okay, and if you remember from what we just said, all right, if my m prime is here, then my m is inside here. And the other function is g prime, all right? And if you're ever not sure what to do, just start with this and see which direction you need to go. If I have m of g of x equals x, and I do the chain rule, then I wind up with m prime of g of x times g prime of x equals 1. And when I solve for this, I get g prime of x. All right? Well, that's not what they asked for on this one. They asked for m prime. So that's why you have to flip these things around and think of it as g of m of x equals x. And when you do the chain rule, you have g prime of m of x times m prime of x equals 1. When you divide both sides by this, you get what I have here, all right? Now, from this point on, from everything that I've just taught you, finishing this is easy. We are supposed to find m prime of 4. So that means I want to find 1 over g prime of m of 4. And if you look up their table, you're like, what the heck? They don't tell me anything about m. No, but g and m are inverses, okay? So if you think about this point m, this means I'm putting a 4 in for m. It means I'm putting a 4 in for x, and I'm looking for the y. Well, guess what? In g, there is, because they're inverses, there is guaranteed to be a point that has a y value of 4. Remember, we went over that right here, talking about flipping the points back and forth. Okay? So we do have information about g. And look at this. Look at this information right here. When I put a 2 in, I get a 4. So guess what? In the function m, we are guaranteed to have the point 4, 2. All right? Because they are inverse functions of each other. And now I know what m of 4 is. M of 4 is 2. So I can put a 2 right here. So this is 1 over g prime of 2. And I've got information about g prime of 2 as well. G prime of 2 is 0.4. I'm out of room here. Let me just come over this way. So this is 1 over 0.4. And they kind of clean that up a little bit. They write it as 1 over 2/5, which is the same thing as 5/2. All right, because 0.4 is the same thing as 4/10, which is the same thing as 2/5. All right, but the most important thing is understanding these relationships that we're looking for m prime of 4. All you really got to start with, everybody, is start with this thing right here. And if you do the chain rule with it, including taking the derivative of x, which is 1, you will get to these special relationships. All right, this one, and in this case, this one. They are both true. If m and g are inverses, both of these situations are true, and you just need to pick the one that works best for you. The problems are not hard if we understand the relationship between inverse functions, and we will stop there for today.